Speaking a little of Daniel, he got his PhD in hydrology at the Institut National Polytechnique de Grenoble in France in 1990. It's a while ago. So anyway, but he has really broad experience in hydrometeorology, radar meteorology, precipitation estimation, hydrologic modeling, and really what he is known and what he has been doing the last decade plus is really impact-based early warning system, impact predictions, and working with stakeholders, emergency managers, and other stakeholders to improve their capabilities of recognizing weather and climate-related hazards and give them tools to better respond to those impacts. And so, let's see, he has coordinated many international projects, particularly in Europe, and these build on each other, and what he is talking today about is really the culmination of the most recent activities that he has been engaged in. And so with that, I really want to give the floor to Daniel so he can speak about what he has been doing. And thank you, Daniel.
Thank you, Matthias, for the introduction. Thank you to all of you for coming today. I will try to make my speech consistent. That means that I will not explain a lot of small details that are in the cooking things, but I will be happy if some of you are interested in going into the details. I think that for today it's better to see the main lines. I wanted to start by this sentence that for me is quite important. It's really helping us to understand. This is a sentence and a document from the International Federation of Red Cross that say that early warning systems are only as good as the action they catalyze. And this is very important because sometimes when we work on the early warning system side, we forget about this. So when a warning is not able to trigger the actions that were supposed to trigger, we can talk about failure of this early warning system, even if the forecast was very good. And this starts to happen often and often, and we can see this happening. And in particularly, I will mention here two cases. The first one was in Germany in July 2021. And essentially the forecast was very good, the meteorological forecast, the hydrological forecast, but nothing happens and we got over 200 deaths. In Germany, when it is not somewhere where there are difficulties to warn and use communication means. That means that the problem is quite important. It's not just something that can happen in some countries, it's something that can happen in very developed societies. Essentially, the situation is more or less summarized here. This is the daily accumulation for the 14th July 21 through the radar network in Europe. It's called Opera, and this is seen through this European flood warning system called IFAS that include not only these kind of capabilities but also the capacities of doing forecast, hydrological forecasts with numerical weather prediction models. So the situation was a situation with a very organized rainfall production, let me say, atmospheric situation and rainfall yield. And unfortunately, even if it was well announced by the European Center of Medium Range Weather Forecast and the DVD, that it is the National Weather Forecast Authority in Germany, nothing happens or nothing happens enough to prevent deaths. This is an issue, and one of the products that IFAS has for flash floods is called the Flash Flood ERIC indicator, and it is for the location in which the major damages were produced, the R River in Germany, and it was issued more than 1 day before. The idea is that there is a combination of the forecasted rainfall from the weather model predictions into something that it is a proxy of the discharges that you will see, but talking in probability. So we have the probability distribution based on numerical weather prediction models, and then we can convert this in return periods of the different elements, the different scenarios that have been forecast in a non-deterministic and a probabilistic model. This is more or less to know that when this system detects a signal over 20 years return period, it produces the maximum alert. 20 years return period is nothing, but it is computed compared with a climatology of the model. We have not 1,000 years of the model. We have a limited period, around 30 years of the model. So overpassing 20 years return period was considered the maximum to make a maximum level of warning. And this is working at European level. Also using the rainfall from the radar network in Opera in Europe, we were able to produce a forecast with a lead time of 5 hours over this R River. So all this information were circulating during the day. The DVD was perfectly knowing what happened, but we fail as a society to transfer this information in a proper way to the people that could be affected. This is Schuld. This is a small village at the R River. And well, the idea is once you have all this information, and you can trigger actions. And this is my purpose today. If you look at this house, and you look at this was pictures from the Google Maps before the event, and this is what happened after the events, the house totally disappeared. And if you go there and look, we know they are located in a place in which when the river will go high, they are in flooding areas. So, and as this, they have, in Europe at least, we have hundreds of thousands of people living in these kind of areas. And this is a problem, but it is the reality today. So can early warnings help at least in saving those lives? Because the house will go. But probably what we can do is try to put the people out before. So this is more the question for today. The second event I want to talk is the catastrophic event in Valencia last October 24, 228 deaths in Spain. Again, a society that should be protected enough for not having this kind of disasters. Let's go in a little bit into the details. I have much more information on this event than the previous one. Can explain you. Essentially, what happened was an event, a situation in which a high altitude cutoff, low pressure system that it is called DANA in Spanish. If you go internet, probably you will find this DANA acronym, that it is more or less the translation in Spanish, plus an extremely warm Mediterranean Sea. You should know that last year was in the historical period, the year in which we registered over the entire planet the maximum temperatures. The record was beaten last year. But for the Mediterranean, is the same. We are, last year, particularly after the summer, and this year, we are recording temperatures in the surface temperatures of Mediterranean that have not been seen before. And this, as you know perfectly, this is the source of humidity and this is the source of warm air that if it is destabilized, can reach this very cold air that it stays in altitude. So the situation was so clear, let me say like this, that some meteorologists start announcing that it was really a big potential of catastrophic floods 4 days before. So 4 days before, the models were giving enough information to know that the situation could be really turning in a catastrophe. As you know perfectly, the models have a signal that it is extreme, but the location, the exact location, the exact time is changing with the days. So 4 days before, we knew that it was a possibility of having something really serious. The forecast from the IMET is the National Weather Service in Spain. Already 2 days before, on the 27 October, we're announcing over 200 millimeters in a wide range of the territory of Spain, all the coast. Then it proved and only detect the red area that it is the most intense precipitations over these Valencia regions. But they reduced to over 150 millimeters for the 29 October. So this was issued 29 October at 0 UTC. And then they correct a little bit during the day, 20 October, 29 October, 15 UTC. It was the last foreseen for the last hours of the day. With this information, the IMET produced warnings. The first, in 28 October, was announcing a quite wide area of orange level warnings. But in the morning of the 29th at 8, it was clear that it was a very small area in which the problem will be caused. It was the maximum alert possible for the IMET, red one. The discussion later has been probably we need another one, black one or violet one, because it is not enough to make the people understand. And 2 hours later, they extended a little bit, but they continue with the red one. So this is more or less the maximum. It was the first red maximum in that area for the year, but you know, this is always, you can understand. With all this information, it's good to know that the day before, the 28th in the night or in the afternoon, the University of Valencia decided to close the university next day and stop the classes. So the discussion about if it is enough information to make decisions, in this case is quite particular because the university decided to close the classes and close the activity. And it was not the red warning already there. So only because of the explanation from the meteorologists of the situation, they decide, because it's a lot of people that goes from outside Valencia to Valencia and moves. And they decide to do this. In the morning, bunch of villages or towns decide to close the schools early morning when the first red warning was issued. But it was only partial. Then the activity continues normally, and to understand the situation, this is the map with some relief, and you have the topography there. You have a situation in which Valencia is located in a flat area near the coast. Then there is some hills surrounded it. It's not very high mountains. It's several hundreds of meters. And then there is another plain where Utiel is located, that it is upper. So there is a good, let me say, change of altitude around 500 meters between these two plains. And this explains also the torrentiality of the discharges in what here is called barrancos. Barrancos means torrents that normally don't have water and are used for many things, even transportation, by the roads. The roads are sometimes located near these torrents that are where the water pass time to time, but the majority of time there is no water. So these barrancos were the reason of this flood. This is the accumulation for the 29th of October, and the main area in white is over 300, but we reached over 700 in certain points, millimeters in one day. So that means an amount of water that it is amazing. That's true. Huh? It was an event that was extreme. We cannot deny this. There was the heavy rains in the morning. It started around 8 in the morning. At midday, at 1, they requested the intervention of the army because they were flooded, seriously flooded. This was the first part. Then the rain diminishes during the day and more or less was like a trap because some people decide that it was over. And it was not over because the big amount of water came later, around 5, 6 in the afternoon on this second area. And then the maximum of the impacts were located here, that it is the flat part near the coast where the torrents and the barrancos go. And for them, it was also tricky because there was not very much rain over them. And it is again another trap. The water comes from some kilometers apart and it reaches this area where the flat areas make all flooded. So this is more or less the situation, and we can see the names in the Valencia. And this was the European flood warning system forecasts on the 27th October. So that means 2 days before. And they were announcing some flash floods in several parts. And this is always confusing, but it is like this. We are translating what the numerical weather prediction models in meteorology are saying into the impacts on the locations. So these Valencia round are good. So we can say that here and here, these violet points that are over 20 years return period were okay. Here in Letour there was also fatalities, so it was okay, but it is a little bit extended in places that were not finally totally affected. But it was enough to make feeling that the situation was coming very importantly. This is the warning on the 27th. And then this is more or less what is behind. IFAS take the DVD and the European Center models, numerical weather prediction models, and transform these into floods or into discharges in different rivers. And when you go over a certain threshold, they issue this kind of warnings related to these thresholds. Of course, 20 years, it's not very threatening or very terrifying, but then you can have things that are much, much larger than this. This is another translation into impacts. This is initially provided by the data project, but now is edited in GOBEYOND. And what we have done there is to transform the indicators of flash floods into impacts through computing vulnerability index that are very, let me say, common, like the number of inhabitants and the roads exposed or the number of infrastructures that can be exposed. And it is presented in small basins, not in administrative units like normally the weather prediction authorities do, but into basins. And this is more logical when you go to hydrological impact. And you can see this was produced on 25th October, that it is 4 days or 3 days and a half before, and the signal of the numerical weather prediction models was transformed into hydrological impacts, and it was clear that the area concerned was around Valencia. Then this was improved in the next evolutions of the model. This is issued 27 October at noon UTC. And we can see that the matrix for the computing the impacts take into account this exposure and the likelihood, and also compute the number of people that is behind, and all these kind of things is information that it is included. And we can see this is the forecast on the 28th October at noon UTC, that again, it is very clear that the signal was stable for a few days. So essentially, we were quite convinced that something important will happen there. I remember you that at that time, the University of Valencia, with the information they got, they decided to close the next day operations. This is on the 29th at noon, and it was a little change, but you know, the numerical weather prediction models do also these kind of things. So once you have this signal, how we compute these signals for the basins. In fact, what we are doing is computing the signal for portions of river. In this case, is at 1 kilometer. The pixel is 1 kilometer. So we can do this for all Europe at 1 kilometer resolution and compute the portion of the basin of this pixel with this kind of risk forecast. And then we can even also add which will be the flooded areas associated to this announcement. So this is also behind all these kind of indexes and impact-based forecasting we are trying to do in our systems. All this was not really available because this is on the, let me say, research mode, but if this product will be operational in IFAS at the end of the year. So we are moving this on the operation at the European scale. Then the precipitation, and this is really impressive. This is the station of the IMET, of the official weather forecast in Spain, and we recorded a daily accumulation 24 hours of 772 millimeters. That means 300 inches in 14 hours, because it was not 24. Normally we do this in 24 hours in a day, but in fact, if you go to the real time, it was 14 hours. The max accumulated rainfall in 12 hours were 720 millimeters, what is huge. It's huge. Huh? That is, I put here that the mean annual rainfall in Valencia is around 500 millimeters, 200 inches. So we were accumulating more than 1 year of precipitation in 6 hours, what is really something that is unexpected. Huh? If you go to this and try to do the return periods, we are over probably 1,000 years return period. But we know that it is not anymore like this. I don't like to go to these calculations of return period because with the climate change, we cannot do it. We know that it changed. The old data are not homogeneous with the new one. And the maximum 6 hours accumulation is 621, and the maximum 1 hour accumulated rainfall, of course, is not 61. It was 185 millimeters. That means 73 inches in 1 hour. So it's something that it is really, really amazing. Huh? This is the accumulation from the IMET over the entire Spanish country, and we can see the maximum there, and the meta accumulation for the area. The area over 300 millimeters was quite extended. We saw this in the previous computed with the radar and the rain gauges more clearly. So all this water that was received by the upper flat area were going through the barrancos and torrents to the lower that were not raining so much, and the people were not really understanding that these warnings were related to them. And unfortunately, the disaster was increased because, it's a regional government that decided to dismount the emergency management system because they are from the right parties that don't believe on climate change. And all this was incremented by the political inefficiencies of the people in charge. And even if it was happening around between 6 and 8, the first warning to the population was around 8:30 in the afternoon when the deaths were already there. So essentially this is. So we have a lot of failures, one after the others, and this explains over 228 deaths. This is the only way. But if we go in detail, of course, this is terrible. This is a satellite picture before and after, and you can see all the areas flooded. You can see not just this very flat part that it is a natural part, but all these, you can see the traces here where the population is, all this was flooded. And these were the places in which the deaths were. We knew. This is a map, official map of the ministry with the flooded areas, of the flooding areas. This is for 500 years return period. I took the maximum, of course, to see. But essentially, it coincides with what we have seen in the satellite images. We knew this was there. And we even have the risk, the flooding risk for these areas, in which the different colors increment the result in euros or in dollars. It's translated to economic impact through the analysis of it is urban, industrial, all these things. How many people live? So the red and violet areas are the most impactful. And they were those that were flooded and where the deaths were registered. So we knew. And normally when it happens this, and you go to the details, you find that the flooding studies were determining that it is a flooding area. But it is very difficult to move the population, very costly. It's a very courageous decision to try to move all these people out of these flooding areas. And essentially, in the past, we have not been able to do it. So this is the situation. Then we can talk about many other things. This is the Rambla del Pollo, that is this barranco increase. And you can see that the gauge station was destroyed around over 2,000 cubic meters per second. They suppose that it reached 2,800 meter cubic per second. It's meter cubic per second, no meters that is said. And but you see, initially at 11, it started growing, then relaxed up to 4 in the afternoon, and this was the trap for the majority of the people, and then very suddenly around 5:30 it starts raining very seriously, and the flooded was there. And this is La Rambla del Pollo. When you see this kind of photos, you can imagine what this means to try to put more than 2,000 cubic meters per second. That means that the speeds are incredible, and of course this cannot be just there. It's flooded everywhere around. Huh? and it goes. And we can see things that we know. In particular in Paiporta, 45 deaths in this small village. Majority of them at their houses, like in Germany, because they didn't understood that they were at risk. They stay at home, and when the river gets you in your house and you have no the possibility to go stairs up because it's just one level, it's like this. This was the foreseen risk area for 500 years. So we knew in advance which are the houses that will be in danger. We know. We have all this information in our computers, but probably no one had all this on the same computer this afternoon that the things happen. But information it is. It exists. This is one of these typical houses, and you can see the level of the water here, 2 meters 37. Of course, if you live there and you stay at home, it's the end. You cannot go out. When the water arrives, half a meter of water is something that you cannot stand on outside. So you wait up to the end. And these are, you can find terrible photos in internet, and this is essentially what happened. You know, the cars float even if we feel secure inside, but when there is flooding, the car is a weapon. So this was essentially what happened. You know, Great Colorado Flood, 2013. Probably you remember, some of you, some others, you were not there. And this was happening here, and it was one of the biggest around in Boulder. And when we see the amounts, it was 9 inches, 231 millimeters in 24 hours. We are talking about more than 3 times more. And if you try to imagine what does mean this kind of disasters we have seen in the previous photos. As climate change is augmenting the frequencies of extreme events, we need to be prepared for this kind of events that were 1,500 years return period. And recording 1 month rainfall in few hours in Europe will be the new normality. Germany, 2021, 200 millimeters in 24 hours, over 40 millimeters in 1 hour, 2 months of rainfall in 24 hours. I have other ones. Alcanar in Spain, the same year, a few months later, 220 millimeters in 3 hours, 77 in 30 minutes, 6 months rainfall in 24 hours. Sardañola, 6 months rainfall in 24 hours, over 300. Tourists in 2024 in Valencia, a year's rainfall in 12 hours, even in 6 hours. But this is not the maximum. The maximum in Europe continue to be Rossellone in 2021, little bit more than in Valencia, 740 millimeters in 12 hours, and again over 180 in 1 hour. These are quantities that are unexpected, totally unexpected, but they are appearing with a frequency that it is not normal. So we need to change our mentality. These are not any more 500 or 1,000 return period floods. This is something that we will see around the Mediterranean at least every decade or even less, because here we have Italy 21, Spain 24, who will be next. Something that probably needs to be thought about, And the thought we can provide is how we can do better early warning systems to reduce damage and save lives. And I want to share with you 3 lessons learned from these events. This is Valencia. You see the blue area is the maximum of rain. The red area is the maximum of the impacts. And the first lesson is the maximum rainfall is not where the maximal impact is located. So we need something that is called impact-based warnings. We don't warn just on rainfall, that is the trigger variable. We need to warn about the impacts, which are who and where will be affected. And it's not the same place, it's not the same people, the ones that receive the maximum rain and the one that will be more affected by the impacts. And this is the first lesson for the early warning systems. The early warning system should talk in impacts, not in meteorological variables. It's the same for the temperature, the wind, whatever. We need to restructure our mind and try to go there. This is not easy, but can be done. This is the flash flood early warning based on radar rainfall estimation at 7:20. The alert, official alert to the phones arrived at 8:30. And we knew that at that moment, the situation was terrible. Between that and 8, the majority of between 7 and 8, the majority of deaths were done. So in this impact-based forecasting, the radar data, the radar forecasting, let me say, quantitative precipitation estimation and forecasting are crucial. So that means that there are plenty of work that should be done, even in our domains, to make possible these impact-based early warning systems. The second is that an early detection system is not an early warning system. So the majority of times we have early detection systems. We forecast something that it is coming, so we are detecting a phenomena. But an early warning system is quite more. We need to convert what we are forecasting in actions. This is the motto from the first slide. We need that the early warning system trigger actions, and this is difficult. We are not used. We need to connect with a number of stakeholders, with a number of actors that make the information goes to the population in a good way. So we need to think about converting our early warning systems in tools that empower to act. How to do it? Well, let me take the example of the flood, and we can take these maps about which area is foreseen to be flooded. This is done previously, of course, it's an hydraulic study, and we can determine the major vulnerable points or critical points in this map and associate to them a label about probability of being flooded. Then, when our systems produce these flash floods or floods indicators with a given probability, we can relate this probability to the points that are in this flooded area and connect any one of the different critical points with these indicators. So the model can activate the warning on the points, and we can look where we are announcing that will be the flash flood or the flood, and then we need to have information about these houses, and probably we can prepare previously the detection of which of these houses are really one level and need to be warned quickly, probably establish a list of, or even an open system to the people to be registered or whatever, but it can be done. but we need to think out of the box and think how to convert the information we have into something that can trigger what we call site-specific self-protection plans. Because one of the things that climate change is showing us is that no system or no administration can protect all the people, because the multiplicity of possibilities and places will be so big that we need to establish this concept of self-protection plans. That means that previously you analyze which is the risk in your village or town or your community, and you set up a plan in which you identify which are the actions to be done and make sure that the population knows. So when this kind of site-specific warnings, that mean it's not for the town, it's not for the region, it's probably for a number of houses in that neighborhood, arrives, they should know what to do. And this is what we are trying to do in Go Beyond, in the project, European project Go Beyond. We are trying to develop multi-risk impact-based early warning systems to support civil protection authorities. And with this idea of, we start with the forecasting, then we do hazard evaluation, include exposure, include vulnerabilities, even in a simplified way, to get a warning that it is located and it is addressed to a specific point that we have pre-identified as vulnerable point, so we can specify for that point this information. Essentially what we have is that in this chain, we have several tools. We have the coordination tool for the regional and national authorities, and then the local tools that try to trigger these site-specific warnings for local vulnerable points and help the communication needs. This is what the project is about. This is a short video on the platform we are developing just to get you some insight. This is able to put multi-risk, multiple layers. Here they will put the flood risk layer, and you can add the pre-identify. You need to work on that. You need to decide that this industry is located in a potentially flooding area, and they need a specific warning for them that will be created by the system, but with the information pre-established by the authority, by the local authority. Then we can go to other hazards like wind, and it's also an integrator of information. You can integrate all the available information. Even we can integrate the 112 calls. The 112 calls in Europe, 112 is the phone of the emergency. Every call that it is produced to this number is geolocated, and the authorities have this location, so you can geolocate the 112 call. So that means that it's a second way to assess the severity of what is happening, and then again in another case. They put the flooding areas and the flooding risk, and you can see even in the small villages, which are the points that will be associated to a certain level of probabilities. If you reach this level of probability, you can send a warning directly to the responsibles of that infrastructure, or can be a school, hospital, in this case is the bus station in these small villages. This is the way in which we work. Essentially, we produce the algorithms that do this impact-based forecasting. We display in systems that are able also to be integrators of data. And then we use the local data from different sources to enrich this and made possible that all the information should be on the same place, from the meteorological forecast, the information of the local sensors, the flood directive risk maps, the 112 calls, and the automatic activation of critical points. We are working this with local and regional authorities. So we co-design these tools and these platforms, and we operate these in demonstrations in 5 regional and 5 municipal pilot sites. The project is composed by 17 partners and plus 10 associated partners from 9 countries, and we have 17 operational authorities and first responder authorities. We work directly with them to design, to understand their needs, and to make the things happen. And of course, for this kind of solutions in which you want to go up to the site-specific warnings, they are crucial. 7 institutions of research and 3 small enterprise, and a community of practice in which we invite externals, over 50 stakeholders that join the meeting of the project. The project will to be multi-risk, and it's not just weather, also geohazards, impact-based, co-design with operational demonstrations to make these site-specific warnings and try to empower to act the population. And I finalize with this video also about the platform to give you an idea of that there is multi-risk information, observations, the official warnings for the next days, different hazards for these official warnings. You can explore all this information through the system, get the sensors. It's really a powerful system that allows the integration of all this information that, as I said, normally is distributed in different places, and when you have the emergency, you have not access, or the authorities have not access. The idea is if we can put all this integrated in a single window, this is much better. Of course, then you need to be aware of what it means, but we are also trying to move these authorities to allow automatic warnings, because as you know, when the things happen, the human beings we have tendency to discuss, and if there is an automatic warning, that means that it is not sent to the population, but the machine is telling you what to do in an automatic way. It's probably easier to focus the attention in what is happening and not to be diverted by other things. So, and this is also for the floods. Again, it's a very nice information when you put your areas in which the flooding can occur, helps very much to concentrate where the impact can be produced and to make this kind of assessment. Thank you very much.
Thank you, Daniel, for a thought-provoking presentation and sharing some of your vast experience in this area of putting information together. I can imagine there must be questions in some people's head. Yep, please go ahead. Maybe I can throw that to you.
Nice talk. So in Valencia, you mentioned that the provincial government or the authorities there had gotten rid of early warning systems because of not believing in that climate change was a real threat, or for various reasons. I'm just curious, in the fallout since this event, has there been any reckoning over the decision by the local authorities to get rid of an early warning system? Is the local population realizing, hey, we actually need this? Just what has the fallout been?
The follow-up is that now is in court, and there is long discussions about who is the responsible, why you were not there, why you didn't make an announcement. It's a long process, and more or less the majority of the people involved don't want to talk, and because this is normal, because they may have responsibilities. But it is nice because the judge is a young lady, that it is the judge in charge in Valencia of that. She's doing a really impressive job, trying to put the things clear and showing all the failures. And it's still on court, so it's difficult that there will be acknowledgements about these things before we don't get the end of these kind of things. But in general terms, all the other regions have started discussions, and, well, you know, the political debate is not very good on these kind of technical subjects, but they should make the decisions. All this is related to a political decision in which level of protection we want to have. And all this is under big discussions. But let me say that it's too early to have this kind of reflection as you propose. But I think that it's so evident. Now, probably you heard that we have hit by the fires, a lot of fires in Spain. I think that it was the worst year in 3 decades. The worst. So when you start seeing all these things, it's quite indeniable that it is something happened. But you know perfectly, you know better than me, that even with these kind of things, the discussions are endless. But we need, as scientists, to be there and prove and show this is our role.
Hola, Daniel.
Hola.
So yeah, I have a question because of Valencia, of course. So I think, like, since I moved here to the US, I feel like in certain communities and certain areas for different hazards, I think that the population is really, like, it's more knowledgeable and well informed, and there's also a lot of studies on, like, risk perception, which I feel like in Spain it's still kind of like a gap there. So in your tools here, it's like, this is impressive, and you're giving like you're empowering the population, but then, like, what's the assessment? What's how the population learns from that, and how, like, what's the action that they take and everything? Who is making that research on, like, how the population is taking this, but just not the population, also the authorities, because I feel like there's a gap there. Like, the scientific community is doing a lot of impressive things, and then I feel like there's no translation into, like, the real action that we could take.
It's true, there is a lot of work to be done. What we are doing is working with early adopters. There are cities that can be early adopters and try to use this internally for the emergency management. And we have also the work with regions, and it depends quite much the advancement of the region, not just with the technology, but also with these ideas of we deliver the information to the population is incredible, but at that time it is still a discussion on some authorities. What we do is to support them, discuss with them, try to be at their side, but we cannot jump over them. The only way to reach really something that it is sustainable is that the local or regional authority takes the hand and decide to go. And it is true, in the next years we will need a better explanation to the population, and also including the new tools, because now all the photos and the videos were streamed by the people that were there, and it was online during the event, so the information is there. But there was no one making structured information available. And this is what we need in the next step, that the authorities can produce structured information or even warnings before it happens. Because if not, it will be led by the social networks. And we know some information is true, but then the false news appear, and it's crazy. But this is something that we need to work a lot, how to make the last mile, the connection with the population. What we do is working with these early adopters and try to help them to be examples for the rest, but it takes time. It's not for tomorrow, but we are working on that.
Yeah, I had a related question about that last mile in it, which is, you know, growing up in Florida, I will say for hurricane warnings, a lot of people just say, I've been here 50 years, I've never been impacted by this, or they always say there's gonna be an impact, and it doesn't happen a lot of times, so I'm just gonna hunker down. So I know you addressed that kind of last piece. It takes, you know, just because you haven't seen in your lifetime it's not going to happen. So how do you take it that last step? And you talked a little bit about that. But then the other side of that is false alarms. So how do you think about false alarms in this kind of framework?
When you approach these early adopters, emergency managers, what we feel is that they are not so worried about false alarms. Of course, you cannot do this every week, but we are talking about things that are very big. And even if it is, in these cases, what happens is that the models can put plenty of, and at the end, there is only one of the 3 or the 5 places. They are prone to accept the false alarms because they prefer to warn and to make the actions, to make prevention, that no actions. But it is true that it is always the critical point. And we know that the meteorological models can produce a lot of false alarms. This is why we work with different time scenarios. Previous days, you only produce a warning that it is for the authorities. And during the day, once you start to have the radar information, you can go to something that it is really sendable to large audience, because you are observing, in some sense, even if there is some forecast there, but you are observing what is happening. But it requires to work with different horizons, time horizons. But I think that we are more aware or more worried about false alarms than the emergency managers.
There's a question online from Jonathan Vai, and he wonders if local governments are requiring that houses in high-risk areas have ways for residents to get onto the rooftop. And that gets obviously into the weeds, that goes beyond the meteorology and the impact prediction. But I think it hints at what are the authorities doing in terms of preventing being in situations where they shouldn't be, or enabling escape routes, etc. So I'm interpreting Jonathan's question here a little more broadly.
Yes, this is an evident question and an evident point that I think that in many places they are trying to do this. It is true that the first option will be move away the population that lives in flooding areas, but it is not possible. First, the people don't accept, and then it's very costly. So we can think about alternatives like this, but it is again like the government comes to you and force you to have an stair or something like that to go to the rooftop. But then you found that these houses are habitated by the elder people that cannot move in a, let me say, not large enough stair to go up. So at the end of the day, I think that it requires that at local level they should manage this and take care of these people before the things happen, and even allow some false alarms. But if you move them 3 times per year and at the end only one was necessary, this is better than doing nothing. But all this is a game of possibilities that any local authority see totally different. And as said, we are working with the early adopters, then the others hopefully will come, but we need at least a few very good examples of success that can convince the rest to move on that direction. But at the moment, this is not happening, at least in Spain.
Yeah, Lulin, last question here. Oh, okay.
Yeah, touch upon the probability and possibility you mentioned. So I wonder, have you include these uncertainty estimate or information into the platform for whatever decision maker to tap on? And at the same time, do you also have a capability to replay the historical event with more quantitative information that's being observed rather than the forecast information to validate how good your forecasts in the past have been? So it's I can imagine you want to include as many hazards and as many impacts kind of events into the platform, and their spatial temporal kind of the scales are very different, and on one platform to represent everything seems to be very complicated and difficult. I just personally want to learn more details in the future. The uncertainty part would be probably the main question.
Well, the uncertainty is driven by the models. So the meteorological models, we work with probabilistic ones, we work with probabilistic translations into the floods. All this is there, but at the end of the day, you need, for the emergency management, you need to press the button, so yes or not. And this is the difficulty when we come from this probability world and we land in the decision management world. Probabilities should be transferred to a decision. So what we do classically is to put thresholds that can combine likelihood and severity, as in a given moment appear the matrix. This is the way in which at the moment these kind of things are done. It's not perfect, but it is the uncertainty is in the models, and then you put a limit based on your experience or the local experience, how many false alarms they want to deal with, and these kind of things, and at the end you get something. This is good because we are working with the users, and the users see this and modify, ask for customization, and customization is very important. The platform can work in different regions, different cities, but all these thresholds, all these decisions are made for the authorities in charge at this local level or regional level. And at the end of the day, this is the best, because at the end of the day, what we want to do from the IT world or from the technological world is that the user feel that the tool is their own tool. They created this tool with you, but they were there to create the tool. Once you get this point that they talk about my tool, this is a success. And this pass for this kind of customization that can be different in a city or another, and make them be aware of which are the decisions behind, which are the thresholds, and if they want to overreact or eliminate some false alarms, we follow them. It's the art of working with the users and customize all the applications to them. And this, I think, it's a key point for adoption.
That's maybe a good point to end here. Thank you, Daniel,
Thank you,
again,
Matthias.
for a
Thank you
wonderful
for
presentation. And clearly, there is many more questions in our minds, and Daniel is going to be here this week and next week. So reach out to him directly or through me to, pick his brain on questions that you have, things you want to know more about it, and he will be happy to engage you in a dialogue. So thank you all for your participation in the seminar, stimulating questions. Thank you, Paul, for all the technology, making it work. Really appreciate that. Thank you.